Legrndre polynomial function Pn of x. Legrndre differential equation has this form: 1 minus x square into d square y by dx square minus 2x into dy by dx plus n into n plus 1 y is equal to 0. Solution of this equation is the Legrndre function or Legrndre polynomial. And the Legrndre polynomial has this form, or Legrndre function. The solution of this Legrndre equation has the form y is equal to a0 x raised to n, a0 x raised to n into n minus 1 by 2n minus 1 into 2 x raised to n minus 2 plus n into n plus 1 n minus 2 into n minus 3 by 2n minus 1 2n minus 3 2 into 4 into x raised to n minus 4 plus etc. Where a0 is the arbitrary constant. a0 is the arbitrary constant. If n is a positive integer, then a0 value of a0 is 1 into 3 into 5 into 2n minus 1 by n factorial. Then the solution y is called Pn of x. That is the Legrndre function or Legrndre polynomial. So the function is Pn of x equal to, instead of a0 I put this value 1 into 3 into 5 into etc. up to 2n minus 1 by n factorial into this term. What? This term. Okay. So this is the Legrndre function of first kind. Legrndre function of second kind is Qn of x. That is another solution of Legrndre's equation. That is, the solution is y is equal to a0 into x raised to minus n minus 1 plus n plus 1 into n plus 2 into x raised to minus n minus 3 by 2 into 2n plus 3 plus etc. Where a0 is n factorial by 1 into 3 into 5 plus etc. up to 2n plus 1. Then this solution is the second kind. Okay. That is Legrndre function of second kind. It is written as Qn of x. And the most general solution of this Legrndre differential equation is, and a and b are two independent arbitrary constants, Pn of x and Q, two independent solutions. Next, Rodrich's formula of Pn of x. That is Pn of x equal to 1 by 2 raised to n factorial into dn x square minus 1 raised to n. This is our formula. We can prove this. V is equal to, taking V is equal to x square minus 1 raised to n. Then dv by dx equal to n into x square minus 1 raised to n minus 1 into 2x. Multiplying both sides of equation 1 by x square minus 1. Then x square minus 1 into dv by dx equal to n into x square minus 1 raised to n into 2x, which is equal to 2n vx. Okay, because this term is v, this term is v. So our equation is x square minus 1 dv by dx equal to 2n vx. Equation number 2. Now we can differentiate this equation number 2 n plus 1 times by Leibniz's theorem. So Leibniz's theorem or Leibniz's formula is this one: dn by dxn into uv is equal to nc0 dn u by dxn into v plus nc1 dn minus 1 u by dx raised to n minus 1 into dv by dx plus etc. So the left hand side, that is this side, this portion is, we can use the Leibniz formula, that is x square minus 1 into dn plus 2 by dxn plus 2 into v plus n plus 1 c1 into 2x. I'm differentiating this term x square minus 1, that is 2x into dn plus 1 v by dxn plus here 1 dn plus dx raised to n plus 1. Okay. Then n plus 1 c2 into 2, that I'm differentiating this term 2x, that I got 2 dn v by dxn. And the right hand 2n into x into dn plus 1 dxn plus 1 v plus n plus 1 into c1 into x, that I'm differentiating x, that is 1 dn v by dxn. And we can use this formula. Okay, all this formula. NCR is equal to n factorial by n minus r factorial into r factorial. N plus 1 C2 is equal to n plus 1 factorial by n minus 1 factorial into 2 factorial. N plus 1 C1 is equal to n plus 1. Okay, we can use this formula here. Okay, I'm rearranging the above equation like this. Then I can use instead of n plus 1 C2, instead of n plus 1 C2, I can use n plus 1 factorial by n minus 1 factorial, and n plus 1 C1, instead of n plus 1 C1, I can use this n plus 1 here. Okay. Then I will get the formula like this, that is x square minus 1 into dn plus 2v by dxn plus 2 plus 2x into dn plus 1v by dxn plus 1 plus 2 into n plus 1 n divided by 1 into 2 minus n into n plus 1 into dnv by dxn. So which is equal to x square minus 1 dn plus 2 into v by dxn plus 2 plus 2x into dn plus 1 v by dxn plus 1 minus n into n plus 1 dnv by dxn equal to 0. This is actually what it is in the formula. It is the form of Legrndre's equation. Okay, Legrndre equation. So that is Legrndre equation is this one. Okay, 1 minus x square into d. I am multiplying with a minus 1. 1 minus x square into d square y by dx square minus 2x into dy by dx plus n into n plus 1 y is equal to 0. So here instead of I, this is dn v by dxn. Instead of dn dy by dx, this one dn plus 1 v by dxn plus 1. And instead of d square y by dx square, dn plus 2 by dxn plus 2. Okay, so the solution is what? dn v by dxn equal to y. Y is the solution. So y is the Legrndre solution of this Legrndre equation. Then I can put a constant here, c into dn v by dxn equal to Pn of x, because our solution is in the form of a into Pn of x plus b into Qn of x. Okay, so p into, so some constant into dn v by d. We can find out the value of c. For that, v is equal to x square minus 1 raised to n. We can written as x plus 1 raised to n into x minus 1 raised to n. Using Leibniz's formula here, dn v by dxn equal to n c0 x plus 1 raised to n into dn by dxn into x minus 1 raised to n plus n into c1 n x plus 1 raised to n minus 1 into dn minus 1 by dxn minus 1 into x minus 1 raised to n plus etc. Okay, we got several terms by using this Leibniz formula, but the first term, this term, dn by dxn into x minus 1 raised to n, that is n factorial. So all other terms contains one term, that is x minus 1 here, x minus 1 here, and we have several other terms in between them that also contain x minus 1 term. That's why I written like this. X minus 1 is a factor in every term except the first term, because except this first term can be written as n factorial. So when I put x equal to 1, here 1 minus 1 is 0, so this term will be 0. Here also 1 minus 1 is 0, this term will be 0, but the first term is not 0 because the first term can be written as n factorial. Therefore, only first term will remain. Therefore, dn v by dxn at x equal to 1 is equal to 2 raised to n factorial. So when x equal to 1, we can written like this, c into 2 raised to n factorial, pn of 1 is equal to 1, because in this form, we have this form. Okay, so here pn of 1, here d by dx. Okay, that is d by dx at 1 is what? 2n factorial. So instead of this, we can substitute here. Okay, therefore c is equal to 1 by 2 raised to n factorial. We can substitute the, find out the value of c. So we can substitute there, then we will get Pn of x equal to 1 by 2 raised to n factorial dn v by dxn. That is, Pn of x equal to 1 by 2 raised to n factorial dn by dxn. Instead of v, I can substitute this x square minus 1 raised to n. So this is our Rodrigues formula.